So hello everyone. I will start just to keep or try to keep the agenda in time. So my name is Mikel Azkarate. I already presented myself. I work for Canonical. I was a little bit spoiled by the previous presentation by Jaume and Temu. So I just wanted to say that I'm not cheating. So I know this is about functional safety, but we just wanted to show maturity in this journey. So we want Ubuntu, we want Linux to be present in critical sectors like automotive, industrial. We will be discussing both. And we took this cybersecurity showcase that we are going to present today as a first step in this direction. Okay, so I'll try to explain you how we did that, why, and some next steps. And for that, we have the agenda. So I'll reinforce the idea of dependability within Linux, how we understand it at Canonical. Again, was a little bit covered by. They were cheating a little bit. They were taking ideas from my from my presentation. Then, as we are using security as a forerunner, I will tell you which were the foundations that we were using for that, which was our compliance strategy, so why we took some decisions. So here the idea was always to do the right thing. So this is something that you have always the temptation to do when you are working on compliance, just checking the boxes and having some things over-engineered, overthink, and just creating processes just to be compliant. This is the thing that we didn't want to do. We just wanted to do the right thing. I will go over the automotive and industrial cybersecurity management system standards, but it was be just the surface, so no boring long documentations today, sorry. And a little bit, I will go deeper into how this is applied in the Linux distro in a couple of examples. Again, it will be not super deep, but just a small examples of the type of processes that we are aligning with the standards. Finally, some success stories and next steps. So let's start by, again, I'll put the same canonical mission. So there are some system properties that are kind of aligned with dependability. For those of you that are coming from academia, you may remember these late 90s, early 2000 classical papers from Laprie and Avicienis, where they were kind of defining the terminology for safety critical systems. And they always said that this dependability term is an umbrella term that is at the same time having a collection of properties of the system. So if you need something to be dependable, it is not just functionally safe, it is not just quality managed, it is not just secure, it is not just available, so it's a collection of things. And that's why we show it here like a Greek temple diagram, right? So if you want to keep dependability like holding there, you need these pillars to be sustaining it, right? And as Temu and Jaume said before, so we have a long history in security. So in this dependability journey, we just wanted to start from the very foundations, the things that we are more strongly based so we can mature and level up accordingly. So some figures here, so those are not up to date, so these numbers are from 4 years ago. But you can see that in Canonical, for Ubuntu vulnerability fixes, for example, we are increasing the number of vulnerabilities that we are fixing every year. This is not only because there are more vulnerabilities, but because we are supporting more LTSs. So as we are supporting longer time windows, right? So you can keep track there, but during the last year, we are fixing more than 3,000 vulnerabilities every year, which is already an impressive number. And the other thing that we have at Canonical is our secure software development lifecycle. And this has been extremely helpful for our cybersecurity management system certifications, because actually we were already doing the right thing. Okay, during this life cycle, we already have threat modeling, static code analysis, security testing, penetration testing, and vulnerability management. And luckily for us, this was kind of matching pretty straightforward some of the main foundations that were requested by the cybersecurity management system standards. So if we go to a compliance strategy, again, what we wanted to do is just approaching these critical vertical domains, automotive and industrial, and we started by the cybersecurity management system. So this is something similar to the functional safety management system that we have in ISO 262. So this is not yet about product cybersecurity, it's about cybersecurity processes. And again, we just didn't want to create new processes that are creating overhead in our processes. We just wanted to do the right thing. And we started thinking on the strategy. So if we were an automotive-only company, of course, it makes sense to develop a SSDLC just by the standard itself, just following it blindly, and we do it. But automotive or industrial are not the single security relevant domains that we want to support, right? So probably this is not the way to go for us. The other thing is that we have many products. So Ubuntu is one of the products, one of the most known one from Canonical, but we have others. And we didn't want to expose all these product engineers to these specific vertical standards, right? And the last one is the gaps. So there might be a gap in our SSDLC that is not covered by one of the, that is demanded by one of the vertical standards, but we may not want to make it part from our SSDLC. So there is some additional complexity on supporting different certification standards. So basically, our compliance strategy, as you may already guess about, is based on our SSDLC. And we understand this as a generalization of different dedicated views. So we have a front end for each of the specific domains. At the same time, if there is a gap, so we are not supporting something specific for 2144, we can implement it in the front end. And if we see that this is relevant, and I will provide you some examples in a few minutes, we can use this just an improvement for our SSDLC. So this is our overall strategy. Is pretty simple, but it was already a big point to have it this established before we started the work. So 2144 automotive. I don't know if any of you is familiar with this one, but it's like the security sister or brother of 26222. And these are the technical chapters of the standard. So here I have put together 5 chapters, and I go bottom up on how we have covered these ones. So again, we have the SSDLC. There were things that we were already doing. So here was easy. There was some terminology that we needed to adapt in the front end. But basically, our threat model was compatible with the threat analysis and risk assessment that was requested by the standard. The standard is asking also for continual cybersecurity activities, on incident response, on vulnerability identification, patching, updates, etc. So this was also already part of our vulnerability management policy within the SSDLC. And then we have the organizational cybersecurity management, where we were defining the security roles, the confidentiality levels, so things that our organization needs to do properly to handle cybersecurity. And this is kind of the thing that we already have with 27K1. And then we needed to tailor things for the standard. So in this 9 to 14, we have something that shapes like the V model, the V cycle. So there we did it to kind of trace requirements to tests. So doing this requirement-based testing that Philip was mentioning before. So we already have it here also for cybersecurity. And this was also a strong foundation for our future work, as we will show. There are some definitions that are interesting here. For example, in the project-dependent cybersecurity management, there is a concept in 2144 that is called off-the-shelf component. And this is basically pretty related to open source, or it could be related to open source. So this is defining, for example, the process to incorporate in your ISO 2144 framework components that were not built according to the standard. So this is a classic example where open source can also be placed, and we have some interesting ideas behind that. And finally, distributed cybersecurity. So automotive is a supply chain-based domain, right? So we need to also define collaborations with suppliers, with customers, etc. So that was all. It wasn't very painful, right, for one standard. So we have a second one, 62443-4-1 for industrial. In this case, I have to say that the industrial counterpart is a little bit more prescriptive. So here we have this -4 for embedded systems. The dash 1 is for the cybersecurity management system, again processes. But there is a second part, dash 4, dash 2, which is for products. Okay, and in this part, in industry, we have, for this dash 2, for the product side, we also have like specific requirements. So the automotive one is a little bit more open. So it is more based in the TARA and the requirements that you derive from the TARA. Here we have more prescriptive requirements that you need to be compliant with. I think it's something like 50, 60 requirements that you need to follow up for a specific product, hardware and software. But in this case, I focus only in the processes, which is our cornerstone. Those are the practices, 8 practices in the standard. For the process, again, dash 1. And here we can find the usual suspects. So we have, again, security management. In this case, the threat modeling process is defined here. We also have something analogous to this off-the-shelf component. So here we have externally created components that are also defined in the standard. This management of security-related issues and security updates is also kind of similar to our policy on vulnerability management. Again, we have the V-cycle here, left side, implementation, and right side. Here for open source, this part is something that we are not explicitly doing, right? The code is already designed and implemented, so we need to kind of describe what we find, right? And see if it is reaching the standards. And finally, security guidelines. So this is one of those examples where we were able to feedback some gaps that we found in our documentation. So here, again, this standard is pretty prescriptive, and there are some requirements on different stages of your product, for example, the commissioning. So this is something that we took an opportunity to also improve our security documentation and feed this back to our SSDLC security documentation. So we were not just trying to apply it, but also learn from it and try to apply it to our overall secure software development lifecycle. Okay, so this was again processes. This can apply to any product that we developed, but what about the Linux distro? So here, I just wanted to show you a couple of cases, will be short again. And I would like to show you these examples with a showcase that is Ubuntu. So maybe some of you already know how our distro is organized. So we have different archives. So we have main, universe, multiverse for different licensed packages. We have restricted for some very few packages that are kind of related to private drivers. But basically we have main and universe. In universe, we are directly taking any public sources. We are packaging them in Debian, and we are having it there. So there is not much scrutiny. There is some scrutiny, but not much. And then we have the main archive, which is our standard delivery. Here we have, to give you an order of magnitude, 2,000 packages. Here we have 30,000 packages. So here we are really taking care of the things that we are putting in this archive. Okay. So again, I already talked you about a couple of concepts in both the standards of the shelf component, 2144, security requirement for externally provided components, 62443. So they are asking for security documentation for those parts. They are asking for mitigations. And we achieved to map this with existing process. Again, we didn't want to create a new process for this, but we already have it in-house. And this is called main inclusion review. And this is basically the process that we are triggering for more than 20 years for the packages that are passing from universe to main. So for that, we are contacting upstream. We are thinking about the functionality. We are doing reviews, and we are resolving issues. And these issues are related to security, which perfectly match. So we were doing coverage scans here, maintainability analysis, installability, buildability, auto package test coverage analysis. So we were able, as one of the mitigations of using open source, just to leverage a process that was already existing in our organization as an evidence of compliance. So this is maybe something that could also resonate on your organizations as things that you are already doing but can fit the standard. Another example, so this archive view is like a static view of our Debian packages, but we do have also a dynamic view, so those packages are changing in time, right? So normally we have like a staging pocket, which we call propose. So here we work on the current Debian package. When we are happy with it, the community is happy with it, we run some regression tests, and if they pass successfully, we can put it in release, we freeze it, and this is our released version, right? But then we have updates. It could be bug fixes because something is not working fine, or it could be security fixes that are not related with functionality, but just vulnerabilities. And I kind of spoiled myself before, but we have 2140 continual cybersecurity activities, management of security-related issues and security updates for 62443. And this is kind of aligned with our vulnerability management process. So normally this is done in 5 steps. So every time we know about a vulnerability, first we need to learn about it, understand it, see if the notification we had is well understood and is relevant. We triage it, so we put a severity level to a vulnerability. Sometimes there are coordinations, and I guess that some of you are familiar with them. There should be some embargoes, some joint communications, and joint work that we have to do with other parties. We have to work on the remediation, the patches, the additional regression testing, dedicated security testing, and finally the disclosure. So here we have a public site, CVE at ubuntu.com, where we are putting all the known vulnerabilities, the fixes, and we are reporting and communicating them. Here is also worthy to mention that we have Ubuntu Pro. So apart from our baseline support for vulnerabilities in main, with this service, we can have vulnerability management also for Universe, and an extended one for main. So this is something that also builds up upon this vulnerability management process. And some success stories. So as you already know, we were certified for both standards, first automotive, next industrial. Again, we were lucky because we have the SSDLC. So mainly the same work that we did for one was working for the other. There was some customization, some front end, as I showed before, where we were doing things specifically for one or the other. They were lesson learned, but now we are targeting the annual review, and this is going smoothly. For the industrial counterpart, there is also a product certification. So here is software and also hardware. So one example is Rector, and Philip also mentioned it before. So this Control X operating system is based in Ubuntu, and they were able to certify it -4-2 for their PLC and their operating system. And we have another partner in Asia, Advantech, that is providing normally hardware reference boards. And they are also offering Ubuntu together with 62443-4-2 compliance services and argumentation support based on Ubuntu. And something that I will like also to mention is a work that was done a few years ago from another Linux Foundation project, Civil Infrastructure Platform, where they were also working like agnostically in community for 62443 compliance. There is an existing GitLab, existing resources, just if you are interested, it's something that you can check. Next steps. So again, back to the pillars. We have security. Again, I have talked to you about organizational compliance framework, software processes for security, automotive and industrial. And now, thanks to the things that we have learned, not only technically, so we have talked about traceability, leveraging existing services and processes. So we have also kind of started a relationship with TubeSud, which is like a two-way relationship, right? We are learning from them, but they are also learning from us, because as you know, Linux is not yet something that certification authorities are used to deal with. So we are really thinking on a long-term relationship there, so we can also level up and affront the next challenge, which is quality and functional safety at the end. And this is me. So thank you very much. If you have any question.
No, it's fine. I'm just curious. Linux is currently treating every bug as a security vulnerability right now, and flooding in the CVE system. How are you triaging that?
So I don't have the details on the triage part, but you mean for the kernel, right?
Yeah, I mean for the kernel portion, yeah.
I don't know, maybe Colin knows from his late times in
No.
kernel. but this is something I can check internally and I come back to you. Yeah.
Okay, that's fine. Thanks.
Hi, Mikel. I have a quick question because from the intro session from Temu, I remember that in the Ubuntu Pro distro there are something like 30,000 packages.
In universe, yeah.
Yeah, something like that now.
Yeah,
I mean,
yeah,
more or less now.
Good, yeah.
Now, it is if I mean I don't know, but I think if you need to pursue, I mean, if you need to achieve a security certificate as a product for 30,000 packages, it seems like a pretty huge amount of evidences, you know, of documentation, you know, to be assessed and analyzed. So my question is, the certificate that you have achieved from a security point of view, are they process certificate or product certificate?
It's process one.
Process, okay.
So this gives us the potential to cover those 30,000.
Okay.
But normally the way we will do that is just
Makes sense. I mean, because I mean, really, I mean, I was trying to figure out how to maintain, you know, the 30,000 packages. I was like, wow. Okay, thank you.
we do it for vulnerability management, so those are supported.
Thank you.
Oh, yep, some questions in the back. Okay.
You to touch on the question that was already being asked. So the like multifold amount of packages that you have to maintain in Universe, do you just maintain all of them and just offer that extended support for Ubuntu Pro users, or do you just offer support for all of the packages that are in Universe, and then the customers still have to choose which ones they're actually using, and you only like do the actual maintenance on those?
For the vulnerability management, I think we are supporting all of them. They can correct me. I know that Mathieu probably knows more, but yeah, we are supporting all of them.
Customer can still choose the one you want. Thanks.
Hi, I'm really excited to see you said you're using Coverty to analyze a lot of stuff in main and also in.
So we were using Coverity. We are also using TioBTX. We have here the CEO. Yeah,
that's really cool.
Which is kind of based in Coverity also from some of the metrics, right?
So one of my questions is, as I actually write software which gets put into Debian and then synced into Ubuntu, it'd be really nice if I could see any of these security or bug issues which that analysis finds, so I can fix them, put them back into the software, and you can get them really quickly, because I love fixing bugs in my own software. So
actually, Coverity has some public scans that you're probably aware of.
Yeah, I use those, but they're not as good as the one which you're probably using.
And we are also kind of scanning our main archive with TioBTX, so this is something that we have already done. But we are also thinking on how to communicate this, because if there is people like you that is happy to have feedback, is great. But if your project is not looking that good, right? Maybe we need to still think on how to visualize this, but this is something that, yeah, we are looking forward to do more.
Yeah.
How do you announce that to the community? Yeah. So the question is, you have some good projects, of course. Everybody likes that, but there are some bad projects. And how are you going to tell the community to fix them? Because they are proud of what they made. So we have to find a way together with Canonical to actually tease them or encourage them to get better. But I can tell you, I don't know whether I'm allowed to say that, Mikel, but there are some kernel projects that are pretty bad. Yeah. So, and that has historical reasons, of course. But there needs to be done something. But we rely on people who do this as volunteers. So that's, you have to be very careful with that.
I'd love to opt in.
Yeah.
If I had the option to see all the bugs filed against software which I work on, I develop, or even help on, I'd just love to see that. And I've dealt with all sorts of false positives because I worked for the Coverty stuff in the kernel, originally in the kernel team, and there are a lot of false positives. So, yeah.
Okay. So maybe we should have an opt-in facility for volunteers. Yeah.
Yeah,
Sure.
Yeah, thank you.
More questions? Oh, okay. Over to this corner.
Just for clarification, in your slides you had orange processes that were covered by the SDLC and then gray processes with vModel. So the gray processes are still gaps or are they already?
No, these are things that we kind of work on them ad hoc. So these were things that we didn't have before. And this is some things that we have been improving thanks to this journey.
Okay.
You mentioned very shortly at the end that you are on a long-term relationship with a certifying body or a certifying company, TÜV, because that's something that's tough, getting Linux into their knowledge. Can you just comment a little bit, what are the kinds of difficulties you are finding? Because I think that's something everyone that works with open source and tries to get it certified goes through, and eventually you can share something of that. What are the pain points where you say, okay, we would like this, we have to preach to the choir here eventually? I don't know.
So there is one point, probably it's not the most relevant one, but I remember, for example, and it was not one of the critical parts of the standard. So I remember for ISO 21444, for example, discussing this part. And I remember the auditor asking repetitively on who from the upstream is going to sign the supplier part. And I was trying to make them understand that there is not a supplier as such, right? So this is upstream community. And it took like several interactions to, so this is like a silly example, but you can find things like this until they start understanding that this is kind of different from what they did before, right? So we also see a value on, once you arrive to this point, not switching the certification authority, because there is like some relationship that has been built and there is an investment there from both sides, right? That's why we are thinking on a long relationship, yeah.
2 more minutes. Yeah, and I just wanted to comment that we very much welcome any one of the certification authorities and people who are doing certification. And some of their input has been very valuable to us in the past and will continue to be so. That community is starting to form here with the forward-thinking ones. So if you've got the folks you're working with, if you want to point them here at this community to come and chat with us and keep the discussions going, I think the more people that are engaged, the solider the results will eventually be and the consensus will be built up. But with that, I think we're down to about 2 minutes, a minute or two left. I think